Good evening once more. Once again, I'm Justin Kunda from Steam and Water Department. So before I start, it's very important that we know some of our keywords we use in boiler. So this is boiler, Chinese guru. It's an important equipment to cool down the off gases, generate steam, the steam which we use to make power. The next word, turbines. It's a high pressure machine. We have two turbines, high pressure turbines and low pressure turbines. So these are the machines we use to generate power. The next machine is the generator. This is the machine that produces power. The next equipment is the condenser. It's also an equipment that condenses steam, change steam into water. The next equipment is the deaerator. This one is also an equipment that we use to remove oxygen. When we are receiving water from water treatment, we remove oxygen from water. That water for us to avoid to damage the boiler pipes. The next equipment is the feed pump. It's one of the most important equipment in our section. It's like the heart. For human being, when the heart stops working, you die. Same like our department. If this pump stops, dangerous, automatically shut down. The next equipment is secretion pump. We have secretion pumps at the converter boilers. Then we also have secretion pumps at ISA. ISA we have 2. Then the converter we have 4. Also very important equipment. The function for this pump is to secrete water from the steam drum to the boiler. Steam drum, also an equipment, boiler equipment. That's where water and steam is kept stored, because water is denser than steam, so water is in the bottom, steam on top. The next way, chain conveyor. You can find this equipment at the converters and also ISA. Another word which is very important is the deionized water. This water comes from water treatment. So before we pump it to the boiler, this is the water we remove oxygen using this equipment. Next word is the boiler feed water. Now this water we have removed oxygen. Now it becomes the boiler feed water after removing oxygen. Another word is off gas. So this one is a byproduct from smelter. When smelter is smelting, the off gas comes to the boiler. So we have to cool down the off gases using this equipment, the boiler. The next word is slag. So slag also is the byproduct from ISA smelting. When they are smelting together with the off gas, comes to boiler. So boiler, we try by all means to remove slag from the off gas, cleaning the off gas before it goes to ESP. It's very important. Dust. So this off gas, slag and dust, these are byproducts from ISA smelting. When they are smelting, these are the items that comes to the boiler equipment. Then we have another equipment, cooling tower. Very important equipment. It provides cooling water to various departments, boiler, smelter, all the departments. Then another word is auxiliary equipment. Auxiliary equipment meaning important equipment for the boiler, for the turbine to operate smoothly. We need auxiliary equipment. Then we have another word is designed pressure. So for the boiler, it has designed pressure which it was made. So that pressure, we call it designed pressure, the original pressure, the maximum pressure. Then we have this word, steaming capacity. It means the amount of steam the boiler can produce. Then another word, important word you hear from our section is power generation. This is the power that comes from this machine. Then another word is steam generation. Steam generation is different with the steaming capacity. This is the steam we make from our boiler. Then we have this word, force secretion. Force secretion means the secretion of water to the boiler. We have different secretions. For ISA, we have 2 secretions. We have natural secretion and the force secretion. So for force secretion, this is the secretion that comes from secretion pumps. Then we have natural secretion. This natural is just natural because here there is no pump. Yeah, just natural secretion due to heat energy. Then ascending chamber. So ascending chamber is one part of the boiler. Start from the furnace, that ascending vertical, we call it ascending chamber. Then this one is the descending chamber. Ascending is going up, descending is coming down. When it comes to the boiler, this is the chamber. When off gas is going up from the furnace, it's ascending, then coming down, descending. From descending chamber, the off gas goes to horizontal chamber. So these are some of the important words you find in the boiler. So introduction, just to introduce our section. Steam and water department is a combination of boiler and water plant. So under boiler, we have 3 sections. We have power station, then we have converter, then we have ISA. Our objective is safety, production, and reducing our company costs. We have to make sure that everyone is following company rules and regulation, and also boiler rules and regulation. If safety is not there, our boiler is very dangerous equipment. It's a time bomb. So make sure that safety is number 1 at our section. Then as the second objection, we have to make sure that the off gas is cooled down. So to achieve this objective, we have to make sure that the equipments that are working in good condition. Another objective is reducing company costs. How do we reduce company costs? 1 is through power generation. When we are generating power, the costs from the ZESCO line somewhere is reduced. Another objective is treating drinking water and also the water that we use in production. That water we use in production, we have to treat it. So basically, this is our flow chart. So our operations starts from water plant, water treatment. That's where we receive deionized water. When deionized water comes from water treatment, it comes to power station, waste heat generator. From here, we remove oxygen. Now it becomes the boiler feed water. We send it to the converter boilers. So when this water comes here, it works in the boiler, becomes steam. When it becomes steam, we send it back to power station due to the fact that the pressure was not stable. So we have stopped now using high pressure steam from the converter boilers. What we are using now is low pressure steam. When it comes to power station, this is the steam that we use to remove oxygen from this deionized water. From the same power station, from the same deaerating tank, another feed pump. This pump is sent, this water which is going to the converters and ISA is sent through the feed pump. When it works here, that water, after cooling, that water now becomes steam. High pressure steam. It goes back to power station. We use now this steam to generate power. After cooling, the output now is off gas going to the acid plant. We have to make sure that the off gas is cleaned, no dust, no slag from the off gas, and the temperature is reduced. When this off gas goes to ESP, then slag and dust remains in the boiler, and we have to remove that slag and dust using the chain conveyor. So that slag and dust, it goes back to ISA feed plant. Here also same process. When off gas and dust goes to ISA ESP, then the dust that remains in the boiler, dust and slag, goes to ISA feed plant. This is the process. Here is the furnace. The heat, the off gas goes to the boiler. To the boiler, there we generate steam. Steam goes to power station. From there at power station, we are using that steam to generate power. So that steam that goes to power station, after running the turbine, we don't throw that steam. We condense that steam back into water. We remove oxygen. Again, that water goes to the boiler. So it's a cycle. We don't waste anything. Waste heat generator stations. One of the systems is the deaerating tank system. This is where we remove oxygen. This system has got these 5 main equipments. We have the deaerator, we have the deaerating tank. This is the storage. After oxygen has been removed from water, it comes to this tank. From this tank, we have our boiler feed pumps, our hearts, pumps water to the ISA boilers. Then we also have other tanks, drain tanks. That's where we keep water, drains. Then we also have drain pumps. These pumps just pumps water back to the deaerating tank. So basically, this system is one of the systems at power station. This system is just to make sure that we remove oxygen from boiler feed water. So this is the system I was talking about. This one is the deaerator on top. That's where the water comes in from water plant. This is the equipment that removes the oxygen. After oxygen has been removed from water, the water is being stored in this tank. This is deaerating tank. It's there at power station 4th floor. This is another view. So this is the tank I was talking about, the deaerating deaerating tank. Then this is the storage deaerating tank. This is the deaerator. This is the deaerating tank. These are feed pumps. We have 3 feed pumps at power stations. 2 running, 1 standby. Another system at power station, turbine and generator system. So for this system, we have high pressure turbines and low pressure turbines. These are coupled together. We use high pressure steam from ISA to generate power. So we have high pressure steam turbine, low pressure steam turbine, and the generator. So these 2 turbines drives the generator for the generator to make power. So these are the parameters: the maximum steam temperature for the turbine. This is the turbine speed, the generator speed. Then this is the maximum out power. This is the generator. These are the turbines. We have the high pressure turbine, and this big one is the low pressure turbine. Another view, the high pressure turbine here. This one is a pipeline, high pressure steam pipe. This is the pipeline. The inlet goes to the high pressure turbine. From here, the steam drives the high pressure turbine. It goes out to the dryer. So when low pressure steam goes to the low pressure turbine, this is the condenser system. So basically, the function for this system is to steam from steam to water. After that water has been changed to steam, we pump it to the deaerator. From there, we remove oxygen. From that water, it becomes now boiler feed water. That water, we send it back to the boilers for cooling, cooling functions. This is the condenser. When steam comes in, it's fine that inside there's a vacuum, and there are 2 bundles inside where cooling water passes through. So when that steam find the inside, there is cooling water. That steam is being condensed into water. Here we have 2 condenser pumps here, condensed water. That water which has been condensed from steam to water, we pump it back to the deaerator, cooling tower. So we need this system to cool down the generator windings. We need this system to cool down turbine oil. Then we also need this system for the condenser. For the condenser to work, there should be this system. So this is our cooling tower. So under this cooling tower, we have 5 secretion pumps. Normally, under normal production, we have 4 running, 1 standby. Then on top of the cooling tower, you have cooling fans. So this is power station. This is how it looks from the outside. So converter section. So this section is also one of boiler section. 4 boilers from converters, converter furnace, and 1 reduction boiler from reduction furnace. So like I said before, basically the function of the boiler is to cool down the off gases that are coming from the converter boilers, remove dust and slag from the off gas. So this section, we have 4 converter boilers, 1 reduction furnace boiler, 1 steam drum. These 5 boilers, they share 1 steam drum. Then we also have secretion pumps, 2 dosing pumps, and the auxiliary equipments. These auxiliary equipments, they are chain conveyors, feed pumps. These are most important auxiliary equipments we have. So basically, this is what happens at converter boilers. So for the converter boilers, the designed pressure is 4.4. Then operating working pressure is 4.0. Then the steaming capacity is 13 tons for each boiler. This is the amount of steam each boiler can produce. These are the standard water quality. For the boilers to work normally, we have to make sure that the boiler feed water, the pH from 8.8 to 9.2. Then boiler steam drum from 9 to 11. Then also boiler drum water conductivity should be less than 150. Then boiler drum water phosphate should be 5 to 15. So this is just the picture I took from the operation computer. So this is the steam drum. These are the secretion pumps. So they are pumping water from the steam drum going to the boiler. This is the inlet pipe. Then this is the outlet pipe going to the boilers. When this water goes to the boilers, it returns back as steam. These are retaining pipes. When it goes to the boilers, it goes as cooling water. When it comes back, now it comes as steam. So now when it comes back as steam, it comes back to the steam drum. This is where it is being kept. That steam now is being sent to power station. This one's the bro of pipe. We use this pipe to control this pressure. So these are the boilers, secretion system. Boiler number 1, number 2, number 3, number 4, and number 5. So these are the secretion pumps for converter boilers. We have 4 secretion pumps. Normally, during normal production, we have 3 pumps running, 1 standby. So these are secretion pumps. These are dosing tanks. So we use this equipment to dose chemicals to the boilers. Like I said before, we have to maintain the standard boiler water analysis standard. It has to be maintained. Yeah. So if the chemicals are not enough, we use these tanks to mix the chemicals to pump to the boilers. So this one is the steam drum, converter boiler steam drum. So all the pipes coming from the boilers, they come to converter steam drum. This is where now steam and water is being kept. This one is a double color water level gauge. We use this double color to check the water level. When the operator operating, we have the remote one and the local one. So it's very important to make sure that the level, the remote level and the local level, they're almost the same. Local is very important because local is the fact. For the remote, maybe the figures they are not okay. So many will rely on these local pressure gauges. So from the steam drum, we have different types of the valves. We have retaining valves. We have also the broad down valves. Then we have ISA boiler. Just like converter boiler, also ISA boiler, the function is just the same. To cool down the off gas, clean the off gas, remove dust, remove sludge. So from 1,200 from the furnace, we have to make sure that this off gas is reduced to 350. That's the standard. So this is the function. This is how the ISA boiler works. So like I said before, we have two secretion types. We have forced secretion and natural secretion. For forced secretion, we use the secretion pumps. Same applies like for converter boilers. ISA boiler also has the designed pressure. ISA boiler was designed to be operating at 4.4 MPa. Then the steaming capacity is 26 ton per hour. At this time now, we are operating our boiler at 4.12. Our boiler is old, so we try by all means to protect our equipment and also people. These are the water standard for ISA boiler. The standard should be in these ranges. So basically, this is how our ISA boiler looks like. We have the steam drum. This is the ascending chamber. We have the connection part, bottom of connection, roof of connection, descending chamber, then horizontal chamber. From here we have two secretion pumps, pump 1, pump 2. This is the active power from the generator. This is the speed. This is the current for the chain conveyor. These are the valves, the pipeline. We have the blow off main steam pipe. Then we have the feed pipe, which comes from power plant, from power station. This is boiler feed water coming to the steam drum. From the steam drum now we have this pipeline going to the pumps. From here now we have forced secretion. We have the cooling panel, perimeter transition, tube bundles, and the roof of connection. The natural secretion is done through the chambers, ascending chamber, horizontal chamber, and the descending chamber and the horizontal chamber. This is another view for our boiler. We have ascending chamber, descending chamber, horizontal chamber. These what we are seeing, these are spring hammers, auxiliary equipment. So these are secretion pumps. These are secretion pumps for ISA boiler. Like I said before, very important equipment. We have one running, one standby. Then this is our steam drum. If you looked at CWHB steam drum, is bigger than the ISA steam drum because there CWHB 5 boilers connecting to one steam drum. This one, just the ISA boiler uses one steam drum. So this is our steam drum, ISA boiler steam drum. They're at 14th floor. Yes, you find our steam drum here. So this is the boiler structure. The whole structure that makes ISA look very beautiful. Though it's boiler here. ISA, we can only find the ISA furnace from 5 floor. The rest of the structure is boiler, ISA boiler. So these are average daily production for our department. If ISA feed rate is normal, if our turbines is normal, average daily we are about to make 1,465 kilowatt per day. Then we are able to generate steam about 1,050 ton of steam per day. We are able to condense about 1,010 meter cubed of water per day. Then this is just last month, June production. We generated about 3,760,300 kilowatts. We are able to generate about 29,760 tons monthly. Then for condensed water, we are able to generate about 27,424 meter cubed per ton. So if you look at these values, steam generation and condensed water generation, it's almost the same. Difference is about 2,000. This difference, the steam that we blow off. We now come to the end of our presentation. Okay, thank you.